Scientists tell us that man has existed on Earth for about 40,000 years. During that time, man has only been able to leave the Earth for very short periods of time, in airplanes or in balloons, but always he has had to return to Earth. Never has he been able to visit astronomical bodies which he may have seen, such as the moon, or stars, or some of the planets. Here is a picture of what the moon looks like if you were actually on the planet Moon. Notice that the mountains are very rough. You may also be able to visit the planet Mars. It is covered with clouds, and for that reason man knows very little about it. If we were to take a trip to Mars, it would take us a long period of time. You see, Mars is a planet which is just outside of the Earth's orbit or path. It takes the Earth approximately 365.25 days to go completely around the Sun. Mars takes 687 days. Now, if we could shoot a rocket directly from the Earth to Mars, it would probably take us about 75 days. But this is almost impossible to do, because the Earth is moving and Mars is moving. And so we must take advantage of that movement of Earth and Mars in our trip through space. Dr. von Braun, who is America's foremost rocket expert, estimates that we may travel to Mars in about 260 days. The Earth would appear at about such a point, and Mars about here. The rocket would leave the Earth and travel in a path which would eventually catch up to and overtake the planet Mars when it reached this point here. This length of time, the length of time it would take, is about 260 days to travel there. Once we have arrived at Mars, or we should say first that Earth would be about at this point right here, when Mars is here. If we wanted to come back right away, I'm afraid we couldn't do it. You see, Earth and Mars must be in a favorable position to each other, because if we shot the rocket from Mars, we would miss the Earth when the rocket hit the Earth's path and could either end up in the Sun or to go on out into outer space. So it requires a wait of about 449 days before we can start to return. During that time, the Earth has gone through one complete turn, hasn't it? And it's also gone to a point right about here. Mars, on the other hand, has reached a point right about here. The rocket will be blasted from Mars, and it will return in much the same way that it left, finally arriving at Earth in another 260 days. Mars, during that time, will have traveled to about here. Now this whole trip, round trip, considering the time it took to go, the time we had to wait, and the time it took to come back, see, that's 9, 16, 9. 969 days, which is about 2.5 years. Now during that time, man must have an environment aboard this spaceship and while he is on Mars. Now what is an environment? An environment is the things and forces around you. Now, what things and forces are around you right now? Well, in your classroom, you have desks, you have an amount of heat, a television set in the room. All these things are part of your environment. Let's consider, if we can, how man will be able to change in this environment. You see, man has a problem. Not only must he get to Mars, but he must also return. Just as this mountain climber going to the top of the mountain must also be able to return before his trip is complete. But what conditions can man withstand in his environment? He can withstand a very sudden change or a large change for only a short time. An example of this would be a firefighter dressed in asbestos suits who could go into a flaming building and withstand tremendous heat for a very short time. But also man in his environment can withstand small changes, such as being cold. Perhaps some of you have been cold out of doors for a longer period of time, but not indefinitely. An example would be this person dressed for winter. If he's cold, he can perhaps stay out all day without suffering too many ill effects. Now, just for a moment, let's consider what are the problems that man must solve before he can exist in space. Well, he must have something to breathe. And since there is nothing to breathe in space, he must take it with him. The substance that he needs to breathe is oxygen. The atmosphere here on Earth is about 1/5 oxygen. Now, this 1/5 is critical. You see, we can't just give man oxygen while he's in space, because if we gave him pure oxygen, it could actually be fatal, because man's body would work too fast. Here on Earth, his atmosphere is diluted, just as paint is thinned if it's too thick, with 4/5 nitrogen. There's other gases here, though. Also, I should point them out. Little argon, some neon, some carbon dioxide, which is important for us to breathe, all are important in diluting the amount of oxygen. But being man will be put under tremendous pressure, air pressure in space, nitrogen dissolves into the blood. And when the pressure is released, this nitrogen can collect into tiny bubbles, and eventually it causes a disease called bends, which is a very, very painful disease. And so for this reason, deep sea divers, as well as people traveling in space, will substitute helium for the nitrogen. What other problems must man face? He must have water, about 4.5 quarts per day, for drinking, for his food, and also for cleanliness. Now, 4.5 quarts, let's see, that makes about 9 pounds, and if we could multiply this by 2.5 years, we would find it's about 4 tons, or 8,000 pounds. Now, that's a lot of weight to carry in a rocket going into space. And so what will be done is the water will be reused again and again. In other words, the 4.5 quarts of water which are used will be repurified from body wastes, such as from the air that you breathe out or from perspiration. So the water then will be reused again and again. Man must also need food. His diet in space for health must contain carbohydrates, fats, proteins, and the other essential minerals and salts. But even if he had oxygen and water and food, he could perish because he wouldn't be able to get them. Now, why couldn't he get them? You see, there's another factor of space travel called weightlessness, meaning having no weight. Perhaps you've experienced it at some time. Have you ever gone over the top of a roller coaster, and just as you go over the top, you almost feel as if you were leaving the seat? For just a moment, you're experiencing weightlessness. Now, in space, they don't experience it for just a moment. They're going to be experiencing it for a longer period of time. Here are some flyers which are experiencing it. You see, are they standing on their head? Let's look at it the other way. Let's see if... No, actually, the first picture was right. You see, they were actually walking on the ceiling, because there is no up or down or sideways, because things just don't go down. Gravity is counteracted in space by other forces. Well, then what has this got to do with our taking on oxygen and water and food? Well, even the air would have no weight. And the carbon dioxide which we breathe out could collect in a large balloon right around our head. And we wouldn't be able to get the oxygen we need. And so fans will have to blow the air about in the ship that we're at, blow the air about the ship so that it'll circulate it. Well, how about water? Simple enough. All I have to do is take a glass of water and drink it. But water doesn't flow down. How about food? That shouldn't be hard. I'll just take some food in my mouth and chew it and swallow it. No, we couldn't do this either. I have a diagram here which shows the process by which man can swallow. You see, the tongue, when you swallow, arches across the roof of the mouth. And then the food actually drops down into the food passageway when you swallow and passes on into the stomach. Now, it drops down, meaning gravity has an effect on it, doesn't it? But in space, weightlessness would not let us have our food drop down. In fact, you could experience this at home, of not being able to swallow. How? Well, stand on your head. And if you can't stand on your head, perhaps you can put your head on the floor and your body up on the arm or chair or back of a chair or sofa and try and drink a glass of water or eat a piece of apple and swallow it. You're going to find it's almost completely impossible, if things are exactly correct, to actually swallow. Well, then how will man be able to take on water and food? Through a system of tubes, similar to a toothpaste tube. In other words, with this rubber tube would be placed in the astronaut's mouth, or in the person flying in space, and the tube would actually be squeezed so that water would be directed down in the back of your throat, down here, and the food would actually be taken up then by your food passageway and directed down to your stomach. You see, this tube can actually be squeezed and the food would come out the end and enter the food passageway. What other problems will confront man? There are many. One of them involves the fact that when he gets to Mars, there could be bacteria there. A man here on Earth is familiar with Earth bacteria, but we've never experienced Martian bacteria. And perhaps they would be different from the ones we have. I have some samples that I have made of Earth bacteria here, which I have made by brushing my hair into a petri dish, which was sterile, some dirt from the bottom of my shoe. I've also got one where I took a swab from my throat, and also one in which I coughed into the dish. I'd like you to look and see the bacteria which resulted from a cough. These perhaps are not fatal, but we don't know what Martian bacteria would be like, do we? Then what other problems must man face? He must also face tremendous pressure. Air pressure. You see, space is a vacuum. And in a vacuum, if there's anything pushing out, it will expand tremendously. I have a vacuum pump here, which will be directed towards the end of this small thistle tube. And it will pump the air, or make a vacuum. And you will actually see where my body, the pressure of my body will force itself down into this thistle tube, or the end of this tube. Let's see what will happen, huh? I'll put it on my arm. See if we can. Can you see how it has pulled the skin actually down this far into the thistle tube? I also notice that it's getting red. And it's getting red because the blood is actually forcing itself out through my skin. I'll shut it off now. It has tremendous pressure. And you can notice that there's a large red ring on my arm, caused because the blood has forced itself through the skin. Now, what is man doing right now to be able to go into space? Within the year 1961, it is expected that the Project Mercury will get underway. Men are being trained to go to the outer edges of our atmosphere, or should I say the fringes of our atmosphere, and return. A rocket from Cape Canaveral, Florida, something like this, will be shot off. Within this rocket will be an astronaut about in here. Now, this portion of the rocket is a safety device. And if something should go wrong, it would carry it and the space capsule away from this rocket and drop it back into the ocean. Now, should everything go all right, which we certainly hope will happen, this spaceship will go into orbit. Not into orbit, I should say. It will be like this. It will begin to make an arc and eventually fall into the ocean. But we must turn this. So with the aid of rockets, this capsule will be turned and actually then put its blunt nose towards the Earth. Now, these rockets will fire. And when they are fired, they will be ejected, and the capsule will begin to ascend or come back to Earth. When it reaches the atmosphere, or the, shall I say, enough atmosphere where a parachute would help, a parachute will open and slow its fall once more. A larger parachute will open, and eventually he will drop into the water where he will be rescued. The whole time of the journey has been 16.5 minutes. During that time, he has traveled 200 miles in this direction. He's gone 125 miles high. His weight would normally be 180 pounds. When the rocket is accelerating, it reaches as much as 1,200 pounds. When he is coasting, his weight is 0. Now, what other problems are there in space? Some of them you may want to solve or learn about. One of these involves heat. I have performed an experiment. Perhaps you could do this yourself if you had 2 thermometers. With the aid of a light and 2 thermometers, one of which I have coated on the end with black shoe polish, and the other I have left as it normally is. And if we place them under a very strong light for as little as 10 or 15 minutes, you'll notice that the black portion will collect more heat. In fact, I've gotten as much as 4 or 5 degrees difference between the 2 thermometers. Now, what does this mean? It means that in space, man has a problem of heat. And this is only one of the ways that man will be able to control it. You see, heat can be as high as 250 degrees on the sunny side of the ship, but on the side opposite the sun, it may be many hundreds of degrees below freezing. What other problems will man face? Here are some that you can think about. How does he sleep? What about radiation? X-rays, which can cause death. These are only some of the problems. Perhaps you may be interested enough to want to read about them. Perhaps someday you and I will be able to see and visit other planets and our moon.
You have been viewing Science Grade 7, a telecourse presented by the Minneapolis Public Schools. Your teacher today has been Richard F. Rumpy. Subject area consultant supervised the planning of each series, which is authorized by the Advisory Committee on Educational Television. Teams of teachers assist in the planning and evaluating of the various lessons presented. Series are produced through the Radio Television Department of the Minneapolis Public Schools. Your studio director has been Louis House.